Definitions of some important terms pertaining to coordination compounds. A. Coordination entity. An assembly consisting of a central atom, usually metallic, to which is attached a fixed number of ions or molecules, ligands. For example, COCl3 NH3 is a coordination entity in which the cobalt ion is surrounded by 3 ammonia molecules and 3 chloride ions. Other examples are NiCO4, PtCl2 NH3 FeCN6 whole raised to the power 4 minus. B. Central atom ion. In a coordination entity, the atom ion to which a fixed number of ions groups are attached in a definite geometrical arrangement around it is called the central atom or ion. For example, the central atom or ion in the coordination entities NiCl2 H2O4, COCl NH3 5 whole 2 plus and FeCN6 whole 3 minus are Ni2 plus, CO3 plus and Fe3 plus respectively. Since it accepts a lone pair of electrons for the formation of coordinate bond, it is also referred to as Lewis acids. Ligands. A ligand is a functional group that binds to the central ion in a coordination complex. The atoms, ions or molecules which donate a pair of electrons to the metal atom to form a coordinate bond are called ligands. These may be simple ions such as Cl-, small molecules such as NH3, larger molecules such as H2NCH2 CH2NH2. Depending on the number of donor atoms, a ligand can be of following types: unidentate or monodentate ligand. A ligand that has only a single bond with the central atom is said to be unidentate, as with Cl-, H2O or NH3. Didentate or bidentate ligand. When a ligand has 2 donor atoms, for example, ethane 1, 2 diamine, H2NCH2 CH2NH2, in which the 2 nitrogen atoms of the amino group act as donor atoms. Polydentate or multidentate ligand. When several donor atoms are present in a single ligand, as in NCH2 CH2NH2 whole 3, the ligand is said to be polydentate. For example, EDTA4- ethylene diamine tetraacetate is an important hexadenate ligand, hexadentate ligand, which can bind through 2 nitrogen and 4 oxygen donor atoms to a central metal ion. When a di or polydentate ligand uses its 2 or more donor atoms to bind a single metal ion, it is said to be a chelate ligand. The number of such ligating groups is called the denticity of the ligand. Ligand which can ligate through 2 different atoms is called ambidentate ligand. Examples of such ligands are the NO2- and SCN- ions. NO2- ion can coordinate either through nitrogen or through oxygen to a central metal atom ion. SCN- ion can coordinate through the sulfur or nitrogen atom. Coordination number. The number of unidentate ligands directly bonded to the central metal atom ion is known as the coordination number of that metal ion atom. For example, in the complex ions AgNH3 2 2+, ZnCN4 2-, and NiNH3 6 2+, the coordination number of Ag, Zn and Ni are 2, 4 and 6 respectively. In the complex ion PtCl6 2-, the coordination number of Pt is 6. In the complex ions Fe C2O4 3 3- and COEN 3 3+, the coordination number of both Fe and CO is 6 because C2O4 2- and En ethane 1 2 diamine are didentate ligands. Coordination sphere. The coordination complex, which constitutes the central atom ion and the ligands, are represented in a square bracket, collectively termed as coordination sphere. The ionizable groups are written outside the bracket, called counter ions. For example, in the complex K4FeCN6, the coordination sphere is FeCN6 4- and the counter ion is K+. Coordination polyhedron. It defines the spatial arrangement of the ligand atoms which are directly attached to the central atom ion. The most common coordination polyhedra are octahedral, square planar and tetrahedral. For example, CONH3 6 3+ is octahedral. NiCO4 is tetrahedral and PtCl4 2- is square planar. Oxidation number of central atom. The oxidation number of the central atom is the charge that would remain if all ligands were removed together with the electron pairs shared with the central atom. The oxidation number is represented by a Roman numeral in parenthesis following the name of the coordination entity. For example, oxidation number of copper in CuCN4 3- is +1 and it is written as Cui. Homoleptic and heteroleptic complexes. The complex in which metal ion is bound to only one kind of ligands is called the homoleptic complex, and when more than one kind of ligands are bound to the metal, it is called heteroleptic complex. CONH3 6 3+ and FeCN6 4- are examples of homoleptic complexes. CONH3 4 Cl2 plus and PtClNH3 5 3+ are examples of heteroleptic complexes.